Hi, let's look at this example under Laplace transforms. So you observe that if I want to find the Laplace transform of the product of these two functions, I can use the integration by parts, and you're just going to end up with something like 2 divided by s plus 3, or 3 plus s to the power 3. Okay, this is what you're going to get when you use integration by parts. But that's integration by parts for this seems to be a bit longer. More especially, there are times when, let's say, this was equals to, let's say, t to the power 6, then e to the minus 3t, or anything. You observe that you have to integrate a lot, like, for it to arrive at the answer that you are looking for. Okay, so now let's try to use one of the theorems that is going to make our work much easier. Remember to say the previous theorem that we used, we called it the frequency shifting or the exponential scaling. But the theorem that you're going to use for this one to try to make our work much easier is called the frequency domain derivative. Okay, so what it is that if I look for the Laplace transform of, let's say, t multiplied by my f of t. Okay, f of t. So for this part, this that you have here is what is your f of t. Okay, that's your f of t. Then everything here is your g of t. So this is just going to be equals to minus um, f prime of what, f prime of s. But you might ask to say, hey, wait a minute, what if I had something like, let's say, look, like the way the question is here, because this one has t to the power 1, okay, but this one has t to the power 2, or in general it can even be maybe t to the power 100. How do you do it? So this is more like the frequency domain derivative, but let me give the general frequency domain derivative notation that you're going to use for the product of two functions that are in this form that you can be given, where the power that you have right here, it could be anything. So what you're going to do is that if you're looking for the Laplace transform of, let's say, t to the n, okay, t to the n, this will be multiplied by whatever that your f of t is. The Laplace transform of this is going to be equals to, so when I put n, it simply means I don't really care what my n is, provided I think in this case, uh, we are going to say where our n is any positive integer starting from 1 going above. Okay, so this is just going to be equals to, I'll say, minus 1 to the power n. So this negative here is affected by what the power of t is. You should always keep that in mind. Then this is going to multiply by what, f, let me just say nth derivative of f with respect to s. Then this is what you're going to get as your what, this is what you're going to be using as your, more like the general point of view for the frequency domain derivative. So let's see, if we apply it, we're going to get the same solution as this. If when I use integration by parts, that's what I got. Now let's try to use this one. So we're going to say Laplace transform of t to the second, where n is equals to 2. Then our f of t is e to the minus 3t. Okay, what are we going to get? So one thing that you observe here is that you first of all have to find what your f of s is. Okay, your f of s. So looking for the derivative of this, I believe by now is very simple. This is just coming from the fact that the Laplace transform of e to the 8t um, is equals to 1 over s minus a. So this is just going to be equals to 1 divided by our s minus our a. Our a in this case is minus 3, so that's going to be plus what? Plus 3 there. That's our f of s. So one thing that you observe is that if I'm looking for f, your nth derivative, and it happens that I'm looking for what? My second derivative of that. So first things first, find the first derivative, find the f prime. Okay, that will be our first derivative. So whatever method that works best for you for such, you can use it. You can use the chain rule, you can use the quotient rule, whatever method that you're able to apply in this case. Let me try to use the quotient rule. My u is equals to the numerator, which is 1, meaning my u prime is equals to 0. My v is equals to the denominator, which is the s plus 3. Then v prime is equals to 1. So this will be equals to u prime by v, meaning this one by that one, okay, which is going to be a 0, minus u by v prime, which is a 1, divided by v squared. That's going to be s plus 3 squared. So just remind ourselves, the um, our f prime, okay, our f prime of s, in this case using the quotient rule, I said it was u prime by v minus v by u prime, divide by, no, 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 not v, that's going to be u by v prime, uh, that's going to be u by v prime divide by v squared. This is just the quotient rule there, just remind ourselves. So this one is just going to be something like minus 1 over s plus 3 squared. That is our first derivative here. Okay, this is our first derivative. We say minus 1. Okay, let's say minus 1 over s plus 3, then squared like that. I can use the quotient rule again to find my second derivative. So we are going to say our u, okay, our u is equals to minus 1, which is the numerator. Then our u prime is going to be equals to 0. Then our v is equals to the denominator, which is equals to s plus 3 squared. Then v prime is going to be equals to 2 multiplied by s plus 3. So this will be equals to this one by that one is going to be a 0 minus this one by that one. But if you say minus, that minus is going to multiply by this minus here. That's going to be positive. So that would be 2 s plus 3, because you said minus, you said this one multiplied by that one, you get it was going to be a minus, but when you subtract it, it's going to be a positive. Okay, so that will be divided by v squared. That's going to be s plus 3. So the squared of this is just going to be what? 4 there, like that. Okay, so now this is just going to be, this one will cancel out. Down here you're going to remain with a 3. So it gives you to say your second derivative. Okay, your second derivative, a prime prime of s is just going to be equals to 2 over s plus 3 to the power 3, because you cancelled out 1 from the numerator, so it's no longer needs to be a 4. And if you observe, I'm supposed to have negative 1 to the power n. What is my n? Is 2. Negative 1 squared is what? Is positive. So you just end up with what? You just end up with this part here, which is that one, and it so happens to be what? To be the transform that we are looking for. So it's just a matter of you knowing the general notation for the frequency domain derivative. Then you can deal with any function that is in this notation, where you treat this one that you have right here as what? As your f of t. So that's how we go about that one. Thank you very much for watching.